We're recording, and we are going to start today with an icebreaker. What's the icebreaker?
What is your favorite app right now?
All right, I did a little research, and I picked a bunch of I was about to say podcasts because I'm looking at my phone right now, and that's the app that's like in front of my face. I went through all my apps, and I made my decision. My decision right now, in this moment in my life, because I believe that your favorite thing can change. It's fluid. My Nike Run app, because I'm really proud of myself. I'm at 91% of my goal. Nike Run app is where I'm at. Other ones I like though, some runner-ups. My podcast app, Google Podcasts.
Runner-ups.
That was not intentional. That was an unintended pun. Spotify is a big one. Starbucks app is a big one for me. And then Pokemon Go. And I have a movie app that I really like. It's not a movie app where you watch movies. It's called Just Watch, but you type in the movie you want to watch, and then it tells you what streaming services it's on.
Oh.
So I'm a big fan of that app too. What's yours?
So like but couldn't you just Google it?
Yeah, but this is like a one-stop shop. Like Googling, you got to like Google it, and then you have to kind of like search through all the, I mean, maybe Googling it's easy, but I find that this app is really efficient.
All right, sure. My favorite app right now, I think, is Libby from the library, because you can borrow audiobooks. And right now I'm listening to Harry Potter 6 in Spanish. And the nice part about Libby is where it beats out like my podcast app is that you can toggle the speed with like a slider. So you're not just locked into like 1 or 1.5 speed. You can do like 1.2, not even 1.25, you can do 1.2. It's great.
Can I try to convert you to the Google Podcasts, because they have a slider.
Oh.
For podcasts, I'm just saying.
What color is the icon? Because I really like that the podcast one is purple, because there's like a lot of not purple on my thing, and I would like, I can't tell, what is that? Oh, that's ugly. I don't like that.
That's a valid reason to not like an app. All right, wait, what are some of your runner-ups?
Runner-ups, well, since it's football season, fantasy football app for sure. That gets a lot of screen time. And then the like Google Calendar, Google Keep. I think those are super duper helpful. But actually, I think I really like having Slack with Google Calendar in it. Ooh. Because then I get like an extra notification. So 1 minute before a meeting starts, I can click on the notification for that and be able to join the meeting instead of like the 10 minutes before. I'm sure there's some way to make Google Calendar do that automatically, but with the Slack thing, it's like really nice. And then there's a messenger app called Viber, which allows you to make GIFs, which I call GIFs because I'm old, but I'm going to stick with that. And so I made a GIF of Daniel Jones running and falling before being able to like get a touchdown. And I am like so proud of it. And then I made a slow-mo version of it.
I'll add that clip in the video right here. So all the students, because you've talked about it now twice, I want the students to make sure they know what we're talking about.
It is so good.
Okay. No one likes the New York Giants.
No one.
You are like my organizational guru.
Oh, okay.
With all your organization tips. I appreciate that.
No worries.
Ready to do some math?
I guess so.
Yeah. We're doing some division today. Taking it back to like, in what grade do you learn long division?
Is it like third grade? Although actually I don't know how they do it now, because they all have like the, you know, like the fancy new way of doing things with like grouping and stuff.
Yeah, whenever parents ask me, hey, what do you think of the new way they teach things? I'm like, I teach things the way I learned it. I always default to third grade. I'm like, when did you learn this? Probably third grade. Third grade must have been a busy year.
I think it was, at least for us. It was like we did like Mad Minute stuff. We did division minute, Mad Minute things.
I remember in math class we had these pawns and these scales, and we did like an introduction to algebra with like weights and like little tiny pawns. You remember that?
Pan balances. We actually, so like I went to school outside of Atlanta, and so like I feel like it was maybe less interactive, like maybe more old school kind of vibes. But yeah, like we learned how to like, what did we learn? I think we started learning about the Civil War, but we also learned that the Civil War outside of Atlanta we learned that it was about states' rights, which is totally not true.
Oh man, we still have a long way to go.
Yep.
I was gonna say something about third grade, but I forget what it was. Oh well. Oh yeah, I was gonna say I went to elementary school where some of our students may have gone. I went to Barnsley Elementary. UCV Barnsley. Where not a lot, but some of the students that we have watching this video may have gone to Barnsley. So go Cougars. Actually, I think they're the Bears now because there's a teacher, Mr. Bear. I had him. And he was an amazing teacher. And they changed the mascot to the Bears because of him, I think. It's pretty awesome.
What?
Yeah.
That's a thing?
But for me, it was the Cougars. Go Cougars. Now it's the Bears.
That makes more sense, though.
How much do you think it's gonna? How much do I have to do in order to get Miss Johnson to change the mascot to the Kirks?
Probably a lot because
Like the Captain Kirks.
Like
a picture of
like an unofficial mascot of Captain Kirk. Like I think that would work, but I don't know about the official, like on all of the sports jerseys and like part of the greeting on InfoFlow. I think that's a tall order. Plus, it doesn't even it's not even alliterative with Blair.
All right, segue to mascots. Let me share my screen. Boom.
Woo!
There's our mascot. Hexagonal blue crab thing.
So it needs a couple more legs.
It needs a lot more. How many legs did? All right. Oh, there you go. All right, let's get started with some math. I'm sure the students are very happy that we're wasting their time right now. All right, so long division, 7 divided by 2. What's the answer?
7 divided by 2.
Yeah, so exactly.
Improper fraction. We like it.
Boom. Perfect. Definitely not 3 plus 1/2, right?
No.
Yeah. So let's do some long division. Let's try to remind ourselves. Do you mind if I do this one first?
Go for it.
Sweet. I'll have you do that second one. Have fun with that. All right. So we have 7.
I shouldn't have said yes.
Divided by 2. We're doing this long division style. All right. Let me just say this real quick. Our topic of the day is polynomial long division. So you might understand why we're doing some numbered long division before we do polynomial long division. All right. Can you talk me through how to do long division?
Well, you got to think to yourself, what is a multiple of 2 that's smaller than 7? But like the biggest multiple of 2 that's smaller than 7. So that would be a 6, right?
6, right? Yeah. We want a 6 here.
How can we take away 6 when we're multiplying? Well, we multiply 2 by 3 to get 6. So that goes up top. Yep. And then 3 times 2 is 6. And then we subtract. So we find the difference. And it's a 1. So then we think to ourselves, well, does 2 go into 1? No. So then you do your little addition thing.
Yeah. So we get that nasty final answer. Before we do that, let's give some names to some of these terms because I think that's going to help us in the long run. I'm not going to steal your color of red. Let's go with purple. All right. What do we call the thing under the division symbol?
I think, is that called the dividend? Because it's the thing that's getting divided.
Yeah, that's the dividend. And then what is the thing that's doing the dividing, I guess?
It's the divisor.
Divisor. Divisor. Sounds like a Star Wars character.
It does.
And then, okay, so we have the dividend and the divisor. What do we call the result?
Is that the quotient?
That is the quotient. And then there's this little 1 down here. What do we call that thing?
That is the remainder.
The remainder. Throwback to Pirate Day. All right, so we have these 4 terms. I think they're going to be important to us later. But when we take a dividend and we divide it by a divisor, we get the quotient plus the remainder divided by the divisor. Right? The remainder never got divided. So in our final answer, we still need to divide it by the divisor. But this equation right here, and with all these words, I think that's an important equation. When you divide 2 numbers, you're going to get a quotient, but then you're going to have a remainder that never got divided. Let's keep that in the back burner. All right, but so let's translate this to the problem that we started with. Let me go back to blue. Oh no, I lost blue. I want blue. Let me go with that blue right there. Boom, boom, boom. All right, so we have the quotient. So 7 divided by 2 is equal to the quotient 3 plus the remainder divided by the divisor. So 7 divided by 2 is 3 1/2. But let's like pretend like that's okay for a second. Mixed fractions.
Well, it's not. I like how this is notating that it's a 3 plus a 1/2. It's less ambiguous.
And because 3 1/2, is that like 3 times 1/2? Is that 3 and 1/2? I don't know. Like that's not mathematically useful when you do complicated math.
Right.
But this
Did you write 31 halves poorly? Like those are all options for how that could be going wrong or misinterpreted.
31 halves. Yeah. All right, cool. All right, so just a quick review of the division algorithm. You want to take over with the second one?
I guess so. But I'm definitely gonna need help with the arithmetic.
Yeah, I got you. I got a calculator right here in case we need it. Let's see if we can do it in our heads first. Let's
so we have our
exercise that brain.
dividend, and we have our divisor. And so now, well,
there we go. Boom.
So what should we do first?
So I'm looking at this 372. And I'm thinking to myself, what is the first number as I scan from left to right of 49023 that 372 can go into? And I believe that's 490.
490. Okay.
Yep. And then is there a number that I can what number do I need to multiply 372 by to get as close to 490 as possible? And I think that's just 1. Because if I double 372, I'm going to surpass 490.
Sounds good. So then we need to take that and subtract it.
Boom.
So we get, it's not 20.
It's going to be 90 plus almost 30. 90 plus 28? 118? We could do some little old school, cross out the 9, make it an 8, carry the 1. I actually do that usually.
Oh, yeah?
118. All right, cool. All right,
but
here's the problem.
That's too small, right?
Yeah, that's too small.
So then we need to borrow a friend.
Borrow a friend? Hey, 2. Can you come help us out?
Come
Thanks.
on, come down here.
It's like a puppy. Come on, 2. All right, so now we got a big number. So we just need to figure out how many times can 372 go into that. My heart, I could be wrong, and it's okay to be wrong because I'll troubleshoot later. My heart says 3.
3 seems like a good estimate, right?
Yeah. So 3 times 300 is 900.
Okay.
And 3 times 72 is 216.
Okay.
So 216 and 900 is 1,116. Yes.
Okay.
And you're just subtracting both. I like that. I like that a lot.
Those.
Boom.
So what do we get? Math. 82 minus 16, right?
Think so? Maybe we should actually do the carry the 1 thing. Some old school math.
Old school. So we borrow a 10.
Yeah, so make that, yeah. So 12 minus 6, it's a 6. Boom.
7 minus 1, also 6. So we got 66.
Perfect. Oh, we need to borrow at 1,000.
Oh, we're borrowing 1,000.
Right? Turn it into 0, bring it over. 11 minus 9 minus, ooh, that's 0.
Yeah.
Boom. You beat me there. You were faster. All right, cool.
Oh,
so we're done, right?
I was just being lazy and like dividing it there, and then seeing if all of those hundreds canceled.
I'm gonna scroll this down a little bit. All right, so we're done, right? 66 is our remainder.
66 is our remainder, but we need to bring this 3 down here.
Yeah, we can't forget about 3.
Can't forget about 3.
Can't forget about 3. So 663. I believe 372 times 2 is going to be in the 700s. So we can't multiply. Yeah, too big.
So we can only take one of them. So we get 200.
Oh, that's an easy one to. Well, not really, but we're gonna get a 1.
This is
and then a 9, and then a 2. 291. Hopefully we didn't make any mistakes.
If we did, though, we'll get yelled at, and it's totally cool.
It's sweet. Yeah, throw it in the comment section below.
Do we even allow the comments? Is that
On YouTube? Yes.
Oh.
And the quizzes, no. But everyone, you should go watch these videos on YouTube a second time because I need those views, and the quiz feature doesn't give me views. All right, so I like what you did there. You're just like, I'm lazy, not in a bad way. You're like, I'm not even gonna write the. So 49023 divided by 372 is equal to. Can you throw an equal sign in between the print on the page and your 131?
Like that.
Wait for it. There, yeah. So 49,023 divided by 372 is 131 plus 291 divided by 372. 131s are quotient. 291s are remainder. 372 is our divisor. There we go. Cool. And we can do an extra thing here. We could multiply this entire equation there by 372 and get that 49,023 is equal to 131 times 372 plus 291. I think that might be useful in the future. All right. That is your daily throwback to third grade. Let's go ahead and do this thing with polynomials. The process is incredibly similar, which is why we just did that. All right. So do you mind if I do this one?
Sure.
Cool. I'm going to write it right over here.
Does that mean I have to do the harder one that comes later?
I mean, maybe. Right? There's my perfectionism. I'm like, I must be completely parallel to the bottom of the page. X squared plus 3x plus 5. That is our dividend.
Dividend.
Doug dividend, or no, the Dimsdale dividend. All right. So
what was that?
That was a reference to the Fairly Odd Parents.
Oh, okay.
Yeah. Show on Nickelodeon, I think. Didn't have cable growing up. Watched it at my friend's house. All right, so we want to do the same thing here. Think of an object. Now we're dealing with polynomials. Think of an object that we can multiply x plus 1 by to get rid of our leading term. So what's that going to be here?
X should do as well.
I think
I just want to cancel out x squared.
Yeah, and we know what x times x plus 1 is. It's x squared plus x. So x squared plus x. And then I'm going to subtract these things.
Can we put in parentheses so that we make sure that we're subtracting everything?
Absolutely. Absolutely. That is a brilliant idea. And it's a very, what's the word?
Responsible.
Responsible thing to do, yeah. So x squared minus x squared, that's just going to be 0. 3x minus x, that's going to be 2x. I guess I could throw a plus there if I want. Cool.
Can we also just like leave off the leading 0? Is that allowed?
Yeah, absolutely. Make ourselves, oh, come on, eraser. There you go. We're talking to the math like it's a pet. All right, so we got 2x. Cool. And I guess you could say my largest power, 2x. The largest power here is 1. Am I smaller than my divisor?
No, because x plus 1, like we can, if we factor 2x, x is a term. There's a factor.
So what can I multiply x plus 1 by to get rid of my 2x?
I think if we multiply by a positive 2,
then
we should be able to cancel that out.
And I'm not going to, I was about to make a mistake. 2 times 1 is not 1, it's 2. And I'm going to subtract this like with parentheses. All right, so 2x minus 2x, that's 0. And then 0. So I think we forgot to do something. Oh. I think we forgot someone. Like we almost forgot this 3.
Oh. Yeah.
How can we need to bring that 5 down.
We do. Come here, 5.
This process is so similar to the division algorithm that you did way back in 3rd grade, if that was the year you did it. And we don't want to, there's all these little things that we need to account for. And then hopefully our final answer will make sense. We'll write it out and make sure it makes sense. So now when I subtract, I'm going to get 0. I'm going to get 3. And then I believe this is a remainder now.
Mm-hmm.
Or because there's nothing I can multiply. I guess I could multiply by like 1 over x. But we're not going to do that. We're going to keep it with positive exponents. No negative exponents. Or so, if this is my remainder, if this is my dividend, if this is my quotient, and this is my divisor, I just love vocabulary words. What equation can I write here at the end?
We can write our quotient plus the remainder over the divisor.
Our quotient plus the remainder over the divisor. And what's that equal to?
That equals our original rational expression.
Boom. And is this like true?
Yeah, I think so. But like just to make sure, like let's think about when these are going to be undefined. So the left side is going to be undefined when our denominator is 0, which is when x equals -1. Mm-hmm. And then on the right side, I think we also get the same. So I think we should be good to go.
I have another way to check too. Let's plug something in. Pick in a number.
5 billion.
5 billion. Pick a number that's easier to work with.
Let's check 1.
1. So 1 plus 3 plus 5. That's 9.
9.
Divided by 2. And then 1 plus 2, that's 3, plus 3 divided by 2. Is it true that 9 halves is equal to 3 plus 3 halves?
I think so.
5.5. 5.5. Cool. There's one last way I think we could check too.
4.5?
Yes. Yes. It is a 4.5. I'm just fixing my handwriting.
Yeah.
We could also take our right-hand side, and then we know how to simplify rational expressions. We could simplify that thing. Multiply this guy by x plus 1 over x plus 1, simplify it, and hopefully it'll become the right-hand side, the left-hand side. There is something, though, I want to do before we move on to the more difficult one that you're going to do. And that is, I want to do what I said before. And I want to multiply both sides by x plus 1 and write this in a new form. I think it's going to make the answer make a little bit more sense. If I multiply both sides of this equation by x plus 1, I'm going to get x squared plus 3x plus 5. Those are going to cancel. And then I'm going to get x plus 2 times x plus 1 plus 3.
Mm-hmm.
I think this is an important equation because this tells us, and I'm running out of room here. Let's see if I have room right here. This tells us that our dividend is equal to our, what is that going to be, quotient times our divisor plus our remainder. I think seeing it in that second way is useful.
Mm-hmm.
X squared plus 3x plus 5 is equal to x plus 2 times x plus 1 plus 3. That's right? X squared, and then the 2x and the 1x gives me the 3x. The 2 and the 1 is going to give me a 2. If I add 3 to that, I get 5.
Mm-hmm.
Cool.
And if you've like read about or heard about modular arithmetic, then this is also like this is very reminiscent of doing things in modular arithmetic, where you're thinking about remainders that you're adding on to the end.
I smell a journal idea. Look up modulo arithmetic.
Modulo?
I think it's modulo. Maybe it's modular. I always thought it was modulo.
I'm gonna look it up.
While you look that up, I just want to say that the similarities between these two types of this algorithm is like uncanny. They're very similar procedures. And the nice thing is we can do this with polynomials now. We can factor them or like get close to factoring them. What was the final result?
Modular.
Modular? I'm wrong.
Modular. But I'm sure if you look up modulo that you'll still get it. Because if you put the arithmetic part.
What happens if you put modulo in general? I wonder what that is. Why have I heard that?
Modulo. Oh, it's a term in like modular arithmetic things. So it's like using moduli, or using a modulus.
Oh, so it's related. I'm not.
Get you there.
Yeah. Cool.
Same root. It's fine.
Mod. Hey, we don't even care about the second half of the word. We just call it mod. All right, you want to take over this more difficult one?
I guess so, but it's going to be more messy. Totally non-parallel.
Oh, yours is better than mine. What are you talking about? I threw in the last quiz a question about whose handwriting is better.
Oh, yeah?
Yeah.
Lovely.
We'll see if everyone gets it right.
Oh, you made it like a right or wrong?
Yeah.
I think it's opinions.
All right.
Okay, so we have our divisor and our dividend. Boom. And so we need to think to ourselves,
Self.
What can I multiply x squared by so that my 2 times x to the fourth will cancel out? And what do you think, Mr. Kirk?
2x squared, I think, right?
2x squared. Okay, so let's multiply 2x squared by our divisor, and we get 2x to the fourth. It feels very Vulcan. Divisor.
It does.
Plus 2x times 2x
Give me a
squared.
Buzz Lightyear of Star Command vibe.
They're different actors, right? Those are totally different actors. It's like Tim Allen and...
Although the Buzz Lightyear of Star Command TV show is what I'm referencing.
Oh, okay.
Completely. Tim Allen doesn't have time for that. All right. What's it going to be?
That's 6, right?
Mm-hmm.
-6. So then,
and then you got the parentheses. Thank you.
Mm-hmm.
Awesome.
And then
Very courteous.
this is going to give us a 0 right here. So I'm just going to write it, but I mean, you don't have to. And then I'm going to write a 0. Because 4 minus 4x cubed minus 4x cubed is also a 0.
That's lucky.
Well, it's very convenient. I don't know.
Mm-hmm.
Lucky. It's convenient. Negative 5x squared minus negative 6x squared is positive x squared.
And let's not forget our friends. Come on.
Come on.
2x. Come on.
Plus
2x. Come on.
Minus 3. All right. Bet. So I'm going to erase these leading zeros because they're unnecessary.
Distracting.
You get a little bit. So then, what do we get? Well, can we... Whoa.
Oh.
Whoa.
What does it say? Wait.
Our divisor is the same as our current remainder.
Yes, I think like...
Just a plus 1. And then we'll get...
Bada bing, bada boom.
We'll just get a remainder of 0. And we'll be delighted. Boom.
And our remainder is 0. So let's write this thing out.
Okay. So maybe we need to scroll down a little bit.
Oh, yeah. I will scroll down.
So
let's use this space right here.
What we're doing is we have 2x to the fourth plus 4x cubed minus 5x squared plus 2x minus 3, all divided by x squared plus 2x minus 3 equals...
There it is. Awesome.
2x squared plus 1. And then we have plus 0 over x squared plus 2x minus 3. But we know that 0 divided by anything is just going to give us 0.
With the exception of 0. 0 divided by 0 is indeterminate form.
That
We're learning this in calculus right now. But we're not going to worry about that.
So then you just get rid of that. And
then
that's like almost correct.
So...
What's the problem, though?
What do you mean, what's the problem? I'm not picking up what you're putting down.
Well, if we have x squared plus 2x minus 3 in our denominator on the left side, doesn't that mean that there's a possibility that we could have undefined points? Whereas on our 2x squared plus 1, that's just a parabola.
Oh, I'm picking up what you're putting down now. Yeah, we have potential discontinuities in the left-hand side, and the right-hand side is not accounting for that. If we are to claim that the left-hand side is the same as the right-hand side, we must clarify that the right-hand side cannot be when the denominator is 0 of the left-hand side, which is, I don't know what that, what's that going to be?
Minus 3? No,
3 and
3.
minus 1, so negative 3 and positive 1.
So then x is not equal to negative 3, positive 1.
Boom. Sweet. So wait, there's one last thing I want to say about this, and that is, if you do what I did before and you multiply both sides by x squared plus 2x minus 3, do we have any room for this anywhere?
If we change colors.
Let's change colors and go right above it, maybe. Yeah.
Yeah. So if we have 2x to the 4th plus 4x cubed minus 5x squared plus 2x minus 3, and we multiply our denominator over, then we get,
oh, I love that color,
2x squared plus 1 times x squared plus 2x minus 3.
What does this thing say?
I think it's saying that 2x squared plus 1 is a factor of that big thing that we had.
No, we don't want to say this again and again and again. I think. And
that our divisor that we had before, that x squared plus 2x minus 3, is also a factor. So we found a factor for.
I think the division algorithm is an alternative way to factor, particularly to factor things that are larger than we normally deal with. If we had given you a couple months ago, I guess at this point, almost a couple months ago when we started doing factoring, that first day of school, the second day of school or whatever, if we had given you 2x to the 4th plus 4x cubed minus 5x squared plus 2x minus 3, you would have looked at that and been like, what? But if we give you a factor, x squared plus 2x minus 3, we didn't know it was a factor at the beginning, but x squared plus 2x minus 3, if we knew that was a factor, we could use the division algorithm to get the other factor. Huh. That might be useful.
Probably.
Let's look at number 3. All right. Is 2x plus 1 a factor of 2x to the 4th plus x cubed minus 2x squared plus 9x plus 5?
Which is essentially asking, can we divide that big long polynomial by 2x plus 1 and get a remainder of 0?
Yeah. Let's do it. Do you mind if I do it?
Go for it. I was going to do nose goes and
then beat me. Yeah. In brick and mortar school, I do the nose game very often to have people come up to the whiteboard. All right, we got 2x plus 1. That's our divisor. Our dividend, I'm not going to say it. Let's do this thing. X cubed. Jinx,
X cubed.
give me a soda. Not a Diet Coke, though. Not a Pepsi.
A case of Diet Pepsi to your apartment.
That's going to be x cubed. Ooh, this is looking good. This happened last time when we were we found the remainder to be 0. Things started canceling.
Yeah.
Let me get that parenthesis for you. Boom.
Thank
0,
you.
0. Bring down my friends. Come on. Come here.
Come on.
Come on. Come on.
There you go.
Okay. What can I multiply here?
Negative x.
Negative x. So negative x times 2x, that's negative 2x squared. Negative x times 1, that's negative x. Let me not forget my parentheses. All right, this is why parentheses really pay off, is when you have lots of negatives flying around. Negative 2x squared minus negative 2x squared. When you subtract the same thing, you get 0. 9 minus negative x, that's 10x plus 5. Ooh, I have a feeling our answer is going to be yes, 2x plus 1 is a factor.
Oh, how do you get that feeling? What? Like, why?
Well, we got 10x plus 5, and we have a 2x plus 1.
Nice.
Yeah, I see what you're saying. And then 1 is not what I want to put here. I want to put a 5, right? 5 is going to get rid of that 10x. I'm going to get a 10x plus 5. Subtract that with parentheses. We get that nice remainder of 0.
Boom.
And if I said, hey, factor 2x to the fourth plus x cubed minus 2x squared plus 9x plus 5. What would you say?
Well, that seems like a problem that I can handle if I use all of my brain. But if you give me the work ahead of that, where you say where we have this division and it's lovely, then I can say, well, yeah, I think that equals 2x plus 1 times x cubed minus x plus 5.
Boom. We have factored. There's only one other factoring technique that I know. We've done a bunch of factoring techniques in the past. We just learned this new factoring technique, division. The only other technique I know is something called the law of ones. Do you know what the law of ones is?
I don't.
It's where I think the average math teacher usually, when they give you a hard problem, 1 is an answer. So if you plug in 1 and you get 0, then you know that's a factor. X minus 1 is a factor. If you plug in 1, you get 0. There's a corollary to the law of ones. The law of twos.
Oh.
So if 1 isn't an answer, plug in 2. If you get 0, that's a factor. There's a corollary to that corollary. The law of negative ones.
Okay.
I'll stop there.
So we're just gonna do all the numbers.
All the small numbers. Teachers don't make the numbers very big. Sometimes they do. Those are the evil teachers.
Those are the very dedicated teachers.
All right, the division algorithm. Oh, you got me! You grabbed me. You've been waiting. You got me. Oh, I love math crab.
Crabbed.
you got crabbed. Oh man, that is going to be a thing for a while now. Okay. We got one last problem here, then we'll wrap this lesson up. And that is, can we use the division algorithm to help us graph things that we have not yet been able to graph?
Yes.
The answer is yes. I should have posed the question much differently than I did. That was not the excellent teacher type of question. I leaded you on. All right, so we have 2x plus 11 over x plus 3. I don't want to point plot this thing. And this
no,
is
that sounds
not
terrible.
And it is not one of our parent functions transformed in its current state.
Maybe we should use polynomial long division, perhaps.
Let's do it. So we need to put this thing in.
Right,
You want it? You got it?
Yeah, I got it.
Yeah.
Mostly because I'm anticipating possibly getting crabbed. And this enables it. So we have x plus 3 is our divisor, 2x plus 11 is our dividend. And so we got a 2, right? So we got 2x plus 2 times 3 is 6. There are parentheses around that. So when we subtract, we get 11 minus 6 is 5. And that we can't do anything with. So we have f of x equals 2 plus 5 over our divisor, x plus 3. And that, I think, Mr. Kirk, is one of our parent functions. It's just been transformed a little bit. Snipping tool.
See, the problem
What
is
is happening?
Bam!
Ah!
See, I can't draw on the screen sneakily because if I scroll, then the recording is going to move with it. I had to, and I did that. I did not do that in a sneaky way at all. I pulled up my sketchbook. I pulled up my snipping tool. I hopefully people are paying attention to you and not to my shenaniganing. Let me how do I delete this picture?
Because I can't move it.
We'll put the crab down here for later.
All right, sounds good. Just save that for later.
So wait, can I inspect what you did because I was not paying attention at all?
That's totally fine.
All right, so your dividend is 2x plus 11. It's inside of the what is that symbol called? The
division house. I don't know.
It's called the division house. And then x plus 3 is your quotient, so you're doing a little bit of division. You multiply by 2 to get 2x plus 6, and then boom, you're at 5. That's your remainder. You have that over your divisor in your answer. 2 plus 5 over x plus 3. Legit. And that, did you already say that looks like 1 over x?
Yes.
That looks like 1 over x with transformation. So let's get some of this stuff.
Wild. So let's just very quickly put our thingy in with our with our parent function. And this is a sketchy parent function. Sketch. All right. Boom. Boom.
Oh, that's our parent. Cool.
All right. And then we need to do what to it, Mr. Kirk?
We need to, I'm thinking about the parent function, 1 over x, and I'm thinking about the order of which I need to do things. I need to deal with that +3 first. That's a domain shift. And the +3 means I'm going to the negative direction. I'm going to the left 3. So I'm also thinking about that asymptote. That asymptote is going to get moved to the 3 to the left. And I think that's all the only thing that's going to happen to the vertical asymptote is that. Because I move it to the left 3, then I dilate it 5, which is the next move. That's not going to change a vertical asymptote. And an up 2, not going to change a vertical asymptote. I'm going to move the horizontal asymptote now, actually, now that I'm thinking about it. That +3 is not going to change an infinitely long horizontal line. The 5 will not change a line that is on the x-axis. If it was a little bit up, it would affect it, but it's not. The +2 is going to affect that horizontal asymptote. Only the vertical shift affects the horizontal asymptote. And I believe, correct me if I'm wrong, I think only the horizontal shift affects the vertical asymptote.
Okay.
That's not true. That's not true. A horizontal dilation might affect the vertical.
Mm-hmm.
Sorry, the vertical.
Like if we had a number there.
Yeah.
Bam.
Yeah, right there. Mm-hmm. All right, so now we've got those. Now I just need to draw a 1 over x graph that's been dilated 5, right?
Mm-hmm. So we go like up 5 from where I am?
Yeah, up 5 from that origin point. Our new, I like to call it like the new origin. It's like when they change all the, never mind.
Okay.
And then let's get that symmetric point because we know that 1 over x is odd. Well, it's odd about the, its point of rotation.
Mm-hmm.
Boom. And let's get one more.
Okay.
Normally we go over 2 from that new origin and go up 1/2. Let's go up 5 halves instead.
And 5 halves is like 2.5 right there.
Yeah, 2 plus 1/2. As we want to do the long division algorithm.
If you want to. Boom.
Boom.
Cool. So now I'm gonna just connect some stuff.
Connect some dots. Sorry for all the
boy.
Discord beeping if you can hear that.
This is pretty bad. I can hear that. It is somewhat distracting, but that's okay.
Sketching on the computer is difficult.
It's like disorienting.
Yeah, I like sketching on real paper way more. I miss those days. When we use these videos in like 10 years, hey, we're gonna look so much older than we look now. We're gonna be old farts.
Very grizzled.
But we're also gonna be like, remember the quarantine days where we had to graph on computers.
That's what we're gonna sound like in 10 years.
In 10 years.
Right.
All right, there we go. We did a lot of polynomial line division. Use it a bunch of times. And wait for it. Bam! I'm so much more lazy on my crab drawing.
Yeah, those like diamond shaped crab claws don't look particularly tasty.
Crab claws are a very tasty food. Oh man.
Maryland.
That's what Maryland does. Crab cakes and football, but not the second one. All right. How do you want to close this one out? Maryland football is awful.
No, we have Tua's little brother now.
Ooh, yeah, but we did terrible the other day.
Yeah, but we have Tua's little brother.
In 10 years, we'll look back at this video and say, what were they thinking? Maryland is the national champion.
Yep.
Crossing
I'm very
fingers.
concerned if
Crossing
your voice
claws.
sounds like that in 10 years. I think we would need to have several conversations about health.
All right, how do you want to close this one out? We already did our icebreaker.
We did.
Should we sing the first line to the Pokemon theme song?
No, I think we should open with that next time. I think we should Maryland fight song it out.
1, 2, 1, 2, 3, 4. Maryland, we're all behind you.
Raise
Raise
high
high
the
the
black
black
and gold.
For
There's
there's
nothing
half so glorious as
than
to
to
see our team victorious. Got the steam boys, you got the team boys. So keep on fighting, don't give in. M-A-R-Y-L-A-N-D, Maryland will win. That was Go Maryland. Go Blazers.
Okay.
No, we need to stop it.